All right, so for those of you who did really well on the test and do not need to review, well, number one, you can go back and review if you'd like and watch the other videos. But I thought we'd take this opportunity to do something I've been wanting to do, which is to show you another method for graphing in standard form. So you'll recall that in order to graph these, they're not in vertex form, and so we have to do it the longer way. So these are all the ones where we're going to have to do negative b divided by 2a. And that's just a little bit annoying and awkward to use. So what we're going to do today is we're going to talk about how we can use completing the square, something you've seen before that we used to solve. And we're going to use completing the square to set up these graphing problems. All right, so the way this is going to work, and again, I'm assuming you remember certain parts of completing the square, but we will kind of go over them as we do this. As we look at this, and we're going to try to figure out how to make this into that binomial squared structure. And what that means is we need this to be a very specific number. In fact, I'm going to pause for a minute, and let's pretend like the problem said 0 equals. I'm going to do it right over here. I'll erase it later. Let's rewrite the problem. Let's just take it and let's pretend like it was a solving question. All right, so in order to use completing the square, we would subtract the 3 to the other side because it's the wrong number. So essentially, we're just kind of moving it out of our sight. We don't care about it. And then we are going to find the right number that should be there. So we're going to take half of 4, which is a positive 2, and we're going to square it, and we're going to add a 4, and we're going to add a 4. And by doing that, the left side turned into x plus 2, the quantity squared, and the right side turned into a 1. And then we did the square root and we solved it from there, right? So that was completing the square. Well, we can do the exact same thing because what I want you to notice is this looks very vertex form adjacent, right? This is very much what the vertex form looks like. So let's go ahead and do the exact same thing, this time with it just with a y equals. So I have my choice. I could, just like over there, I could choose to subtract the 3, but that'll give me a y minus 3 equals. And I don't really want that y minus 3 because with graphing, I want y equals. So I would just have to bring that 3 back in a minute. So we're going to try something a little bit different. We are going to, instead of ignoring the 3 by moving to the other side, I'm just going to do something a little bit weird, and I'm just going to write it down further away. And then I'm going to complete the square, ignoring that 3. So I'm going to take half of 4, which is 2, and I'm going to square it. So I'm going to add 4. And so now the standard rule of thumb would be if I add 4 on this side, I should add a 4 on this side. But if I add a 4 on this side, it's going to be of something that I'm eventually going to want to bring back over because I want it to say y equals. So there is another thing that you can do to balance out adding a 4. And it may sound crazy, but if I add a 4 and turn right back around and subtract a 4, then I have added 0. I've done nothing to this problem. But why is this helpful? Because and you don't have to do this part, I'm just trying to show you visually. If I group these first 3 terms together, this is what I was trying to create. And that turns into x plus 2 squared. And then I have a negative 4 plus 3 just hanging on over here. And I'm going to combine those together and I get minus 1. And so I'm at y equals x plus 2, the quantity squared, minus 1. And now I am in vertex form. So compared to what we did before, it's basically the same thing. The only difference is I'm not moving things away to the other side because I know I'm just going to have to bring them back at the end. Okay, to show that, here's what it would look like, and it's perfectly fine to do it this way. If I redid this problem and followed more of what we did the first time we did completing the square, which is let's move the 3 to the other side. That'll give me a y minus 3 equals x squared plus 4x. I take half of 4 and I square it, and I add a 4, and then I go to the other side. I didn't leave myself very much room, and I add a 4 over here too. So this side becomes x plus 2 squared, and this side becomes y plus 1. And now I want it to be y equals, so I'm going to move the 1 to the other side. And so I've got to bring the 1 back over here, giving me exactly what I got above. So it is perfectly fine to move the 3 to the other side and add on both sides, just like we've been doing. And then you just have to bring the number back. For me, it just seems like an extra step to have to bring the number back. So instead, I take care of it all on one side. All right, let's look at it again. So it's really simple. I'm going to assume that 10's the wrong number. I'm going to slide it out of the way. Half of 8 is negative 4. I'm going to square it and add 16. And I'm going to turn right around and cancel it or balance it out by subtracting 16. Why did I do that? Because when I focus on the first part, that's going to factor into x minus 4 squared minus 6. I am in vertex form. And the nice thing about putting in vertex form is that it can kill two birds with one stone. If I ask you to do two things, graph this function and find when it equals 0. Well, now the work that I've done to graph it is set up me finding the answer to when it's 0 as well. Because now I can graph it very easily in vertex form. Faking it here, I'm going to go over 4 and down 6, and then I'm going to graph it, right? So it's going to look whatever, like that. And then I'm looking for these values. Well, how do I find those values? If I were to plug in 0 for y, I would answer the question about what the zeros are. And since it is in vertex form, now it's very easy to solve with a square root. I can add a 6 to both sides, and then I can take a square root, and I'm halfway to my answer with almost no work. Okay, so that's not really what we're here to do. I just want to point out that the reason most of us who move on and do more advanced mathematics prefer using completing the square to the old school negative b over 2a is because it sets us up to easily graph, but it also sets us up to easily solve. It gets us halfway to the answer. All right, and then the downside. So completing the square will only work when we have an x squared. It will not work with a 2x squared, which we did when we solved it originally. The difference here is I don't want to, just like I said before, I don't want to move everything to the other side. So if I start and divide everything by 2, I can do that, but it's just going to mean I'm going to have to bring the 2 back at the end. So we'll do it two ways. Let's go ahead and we'll do it the way I don't like. The way I don't like would be, I don't like this 2 here. So I'm going to divide everything by 2. Now, when we did this originally for solving, it equaled 0 on the other side. So 0 divided by 2 was 0, and so the 2 just left the problem. But here, the 2 does not leave the problem. So I have y divided by 2 equals x squared minus 4x minus 3. I'll move the 3 over. Negative 2 is half, add a 4, subtract a 4. This part factors, and this is negative 7. But the only difference here is now it's y over 2 equals. Now I got to put the 2 back, and I have to do it right. If I multiply both sides by 2, I have to multiply all of the side. So over here, it becomes y equals, but over here, I have to multiply the first term by 2, and I have to multiply the last term by 2. And I get my answer in vertex form. All right, so let's all look at that in an alternative way. Instead of having to bring the 2 back, let's never move it to the other side. So instead, let's factor it out. Okay, so here is what I'd like you to think about doing. Since I don't really care, let me rewrite the problem here. Since I don't care about that 6, I so don't care about it that I'm not even going to bother factoring a 2 out of it. In fact, what I'm going to do is I'm just going to factor the 2 out of the x squared and out of this term, which will make it minus 4x. Then I'm going to give myself some room inside the parentheses, and I'm just going to stick the minus 6 out here by itself. And I can do that because if I now distribute 2x squared minus 8x minus 6, it's the same math problem. Now we're going to complete the square. Half of -4 is -2. -2 squared is a plus 4. So we're going to stick that right there in the back of that parentheses. So now I need to cancel it out. I need to balance it. So one would make the mistake of thinking since I added a 4, I need to subtract a 4. But I did not really add 4 here. What I really did was add 8 because it's inside the parentheses. 2 times 4 is 8. So if I'm going to multiply or add a 4 here, I'm really adding an 8. So what I have to do is recognize that, and then I have to subtract 8. The parentheses part factors into x minus 2 squared. This 2 comes down. -8 minus 4, or minus 6 is -14. And I get the same answer I got before, but I didn't have to move things to the other side and then move them back. You can. It's fine. I think if you are good at math and good at paying attention to details, then it's just easier to leave everything on one side. Perfectly fine if you want to do it the other way. All right, so please practice this method. I think if you get good at this, you will find that it's going to have great benefits to you in other areas of math. Negative b over 2a is really just sort of the introduction level. It's the, hey, remember how we taught you this? Nah, now forget it. Let's do it the better way. And you guys can certainly handle the better way. All right, go practice, and we'll talk to you later.